All right, we're going to go on to lesson 2, which is talking about similar figures. Congruent figures were two figures that were the exact same in shape and size. Similar figures are going to be having the same shape, but not necessarily the same size. One of the figures could be larger or much smaller. So the definition of similar figures, a basic definition is figures that have the same shape. They have the same shape, not necessarily the same size. Or we could go a little bit further. The mathematical definition is all of the corresponding angles are congruent, which means it has the same shape, but the corresponding sides are proportional, which means each side is multiplied by the same scale factor. This is talking about how they might not necessarily have the same size. One of the shapes could be larger or much smaller than the original. The symbol for similar is just one squiggle sign. That's very similar. It's very similar to the congruent. The congruent sign had that equal sign underneath the squiggle. Since these shapes are not the exact same, we don't have the equal sign there. Just that little squiggle that shows they're similar. So let's talk about scale factor. Below, triangle ABC. ABC right here is multiplied by a scale factor of what to get triangle DEF? Ooh, let's see. Well, and now I know that ABC is similar to DEF. Order matters, so A corresponds to D, B corresponds to E, and C corresponds to F. Notice that in these two triangles, they're not in the same orientation. One was kind of flipped over, so sometimes you have to do some flipsings in your brain. But let's see, let's try to find what sides correspond to each other. AC corresponds to DF, and I went from 10 to 5. So this one was my starting one. I started with 10 and got to 5. Therefore, I multiplied by a scale factor of 1/2, or divided by 2, I should say, to get the second triangle. What's the measure of side DE? Oh, well, what corresponds to DE? DE, AB corresponds to DE. So 6 times 1/2 would be 3. So when you're doing scale factors, right there, when you're finding similar, you're just trying to kind of pair up this corresponds to this one corresponds to this one. So similar figures have what two properties? We already talked a bit about this. All of the angles, all of the corresponding angles are congruent. The angle measures do not change. So in this particular example, A corresponds to D, angle A corresponds to angle D. The measure of angle A is going to be the exact same measure as angle D. The angles do not change. However, the sides are proportional. They have proportional sides. And that simply means when I take one of these sides, let's say AC, and I divide it by this corresponding side, DF, that's going to have the same value as when I take this side, AB, and I divide it by its corresponding side, DE, and that's going to have the same value as the other one. Was that BC? Divided by EF. They're all going to have the same value. They're going to have the same proportion. And that, in this case, is going to be 1/2. Actually, in this case, because I did them this way, AC, this is going to actually be 2/1. Order matters. Yep, because that would be 10/5, which is 2/1. So all of the sides are proportional. When you divide them by each other, they all end up with the same ratio. True or false? Similar figures are never congruent. What do you think? False. You can have similar figures technically. They can be the same. They can be congruent because they're proportional sides. Their ratio would just be 1 to 1. not 2 to 1 or 5 to 1. It would just be 1 to 1. So similar figures can be congruent, but usually when we're talking about similar figures, we're making the assumption that they're not congruent, that one is bigger or smaller than the other one. All right, so again, here are some notes for you. Similar figures have the same shape, but not necessarily the same size. They can, but we're assuming that they don't. All the corresponding angles are the same, and all the corresponding sides are proportional. So we can solve problems with similar figures by making a proportion, by basically setting two ratios and making them equal to each other. When we're writing the proportion, make sure that we're writing them in the same order. Order matters. So let's go ahead and do example 1. We need to find x. I know that these two triangles are proportional because I have these two angles are the same, these two angles are the same, and these two angles are the same. It's a right triangle. So therefore I know that these are going to match up and these are going to match up. So I'm going to set a proportion. I'm going to call this one the small one and the big one. So small over big is the same as small over big. This is a really easy one to set up. We obviously know it's a 1 to 2 ratio, so I could just multiply this one by 2 to get this hypotenuse. But if it wasn't such a nice problem, you could always cross multiply as well. And you could do 12 times 7.5 equals 6 times x. Divide by 6 and use your handy dandy calculator. And 12 times 7.5 divided by 6 equals 15, which is what we would have gotten if we would have just multiplied this one by 2. Oh, centimeters. Remember units. So it would not work if you were to mix up the order. For example, if I were to do this part over this, and then, I don't know, maybe do this one over here. Like if you're mixing up the parts and things, you're not gonna end up with something that's correct. So make sure that your order matters. Example 2, we might have to draw a picture for this one. A tree casts a shadow 10 feet long. A 5 feet woman casts a shadow 4 feet long. How tall is the tree? Well, let's just draw a quick picture here. Here's my tree. And then here is my woman. Hello. All right, a tree casts a shadow 10 feet long. So here's that. I probably should have put my woman over here. I'll just move my woman to make my picture easier. Go away. All right, tree casts a shadow 10 feet long. So here's my shadow. And a 5 foot woman, so she's 5 feet, casts a shadow 4 foot long. So this is 4 feet. How tall is the tree? Well, here I have proportional triangles. I have similar triangles. I know that just the way that the sun works, this angle is going to be the same as this angle. These are right angles. This angle is going to be the same. So we have similar triangles. So I can set up a proportion. I'll do x over 10 is going to have the same ratio as 5 over 4. There's lots of different ways that you could set up your proportion. I could have also done x over 5 will be the same as 10 over 4. You'll notice that we're going to get the same answer either way. If we cross multiply, here we're going to get 4x equals 50. X equals, let's see, 12.5. And then here, cross multiply, I'm going to get 4x equals 50. Same thing, x equals 12.5. So as long as you're staying consistent in how you set up your proportion, you're going to be okay. So we have 12.5 feet. So the tree is 12.5 feet tall. All right, similarity doesn't only work with triangles, it works with any sort of polygon. So here, find x and y. We know, I'm going to tell you that these polygons, these hexagons, are similar. So let's take a look at the angles. We know that all of the corresponding angles are equal. So if this angle is 128, that angle has to be 128. So 3y plus 8 has to equal 128. And so we'll just go ahead and solve. Okay, y equals 40, lovely. Now with our sides, I know that these sides correspond and these sides correspond. I'm always trying to look for a pair of corresponding sides that, like, I have both sides. I know both things about. That's going to be the one that I'm going to start with. So I'm going to go ahead and do 45 over 20 is going to have the same ratio as 5x minus 25 over 2x minus 8. So did I stay consistent? I'm going to call this one my bigger one and my smaller one. Big over small is the same as big over small. Yes, I stayed consistent. All right, now I'm going to cross multiply. 45 times 2x minus 8 is the same as 20 times 5x minus 25. I'm going to use my distributive property. And I get 45 times 2x is 90x. 45 times negative 8 is negative 360. And 20 times 5x is 100x. And 20 times negative 25 is negative 500. I would like to get my x's on one side. I'm going to get them on this side so I can get a positive x. And I'm going to add 500. All right, so negative 360 plus 500 is positive 140. And 100x minus 10x, or 90x, is 10x. Divide by 10. And we get x is 14. Woohoo! And I should be able to plug this back in. Let's see, 5 times 14 minus 25 is 45. Ooh, that matches. I'm going to assume that these are going to match as well. 2 times 14 minus 8 is 20. Excellent, and that makes sense for my picture as well. All right, hopefully we're getting the hang of setting up proportions. Example 4, find h. Oh, h is right here. Ah, I found it. That's not what we mean. Let's take a look. We have some triangles. I have this triangle ADE. So triangle ADE. And then I have this smaller one inside. I actually know that triangle ADE is going to be similar to this smaller triangle ABC. I know that because, well, they share this angle, A and A, right? A is going to be congruent to A. B and D are both right angles, so those ones they share. So by matter of deduction, they're going to have to share this angle, because if A is the same, then then the other angle is also going to be the same. So these triangles are similar. So I could set up a proportion. Okay. Let's see, what corresponds to what? Let's see, AB corresponds to AD, this whole thing. So I'm going to do small over small to big. Let's see, so 6 over the whole thing. Uh-oh, what's the whole thing? Careful here. It's not 12. 12 plus 6 is 18. The whole thing is 18. So that's something to be careful of. That's going to have the same ratio as this side, 0.9, to this side, h. So I did small to big is the same as small to big. Then I can cross multiply. Or, I mean, technically I wouldn't even have to cross multiply. I realize that 6 to 18 is being multiplied by 3, so I can just multiply that one by 3. So 0.9 times 3 is 2.7. H is 2.7 meters. I would have gotten the same thing if I cross multiplied as well. All right, number 5, it's a similar type problem. I have a triangle within a triangle. I know that triangle ABC, triangle ABC is going to be similar to triangle ADE. For the same reasons as last time, they both share angle A. They both have right angles here, and so therefore C and E have to be the same just by matter of deduction. Okay, and I want to find X. I want to find this value right here. Ooh, well, let's see. I know that this triangle, like I take a look at BC, is going to correspond to DE. Well, I know that this triangle is 1/2 of the big one because 3 is 1/2 of 6. But this is 4, but this whole thing right here, if I were to label this whole side, this is technically 4 plus X. Ooh, that's a little bit tricky. You know what? I'm just going to go ahead and write a proportion for that one. I'll go little to big. So my little side, BC, over the big side is going to be the same as this little side, which is X, over this whole big side, which is 4 plus X, or X plus 4. All right, here's where I am going to cross multiply. I'm going to do 6 times X is the same as 3 times, I'm going to flip these around, X plus 4. 4 plus X, X plus 4, same thing. I'm going to simplify. I'm going to use my distributive property. 3 times X is 3X. 3 times 4 is positive 12. And I'm going to subtract 3X. I get 3X equals 12. X equals 4. All right, does that make sense? So if this one is 4 and this part is 4, then the whole thing is 8. Oh, that makes sense. 4 to 8. 4 is half of 8. That makes sense. All right, the next one, study the diagram below. I just want you to take a moment and explain in your own words how scale factor and proportion are connected. So obviously, this is a square. All squares are proportional because they all have the same shape. This one's 2 centimeters, this one's 4 centimeters. They are being multiplied by a scale factor of 2. And then I want you to connect proportion. Like when I say that these sides are proportional, what does that mean? Just take a moment and verbalize that in your own words. Pause the video. All right, last examples. We're going to use scale factor. A lot of times we use scale factor with maps. So a map scale is 1 inch to 24 miles. This little dot dot right here is talking about ratios or scale factors. So I have a map of the United States and 1 inch on my map is equal to 24 actual miles. About how far is it between 2 cities that are 5 inches apart on the map? So again, I can just write a ratio. Let's see, I can do map to real size. So that'll be how I write my ratio. So the map is 1 inch to 24 miles, and that's going to correspond to 5 inches on the map, and I don't know how far they are apart in real miles. So again, I wrote a proportion, made sure that they were in the same order, and now I just have to solve it. And I could cross multiply if I want to, but I'm going to just realize that this is being multiplied by 5. So 24 times 5 is 120. So the cities are 120 miles apart in real life. So So again, easy setting up your ratio, your proportion, just stay in order. Number 7, model trains are usually built in 3 major scales: HO scale, N scale, or O scale. Mrs. Gruber's dad has a model train boxcar in HO scale that's 3 inches long. How long would the actual boxcar be? Okay, well, what is going on here? So if I have a little boxcar, here it is, hello. And then that's actually to scale to the real boxcar, hello. And I take a look. He has an HO scale, so I'm dealing with this one. An HO scale train is 1/87th of the actual length. So that means if this is 1 inch, then this side here would be 87 inches. Well, let's see. And his train is 3 inches long. So how long would this be? Well, let's see. 1 to 87 is being multiplied by 87. So 3 times 87 is 261. So it would be 261 inches long. I probably wouldn't write inches. I would probably say feet. So I'm going to divide 261 by 12. And that's what, 21.75 feet. Which that makes sense to have a 21-foot car. What's the difference between example 6 and 7? Example 6, we are actually our ratio is actually in 2 different units. So I have inches versus feet, or miles, sorry, inches versus miles. Here, when I'm taking 1/87th, I'm actually keeping them in the same unit. So if this is 1 inch, this would be 87 inches. If this is 1 foot, this would be 87 feet, so on and so forth. But you can set up proportions using both of them. Just be aware of what your units are.